Hello, and in this video, we're going to explore another type of potential energy, so-called elastic potential energy, or the potential energy within a spring. Now, as we've mentioned, this is actually important not just for springs, but because so many different things can be modeled by springs, from atoms, which we can think of a diatomic molecule as two atoms connected by a spring, to the tendons in your arm can be thought of as springs, muscles can be thought of as springs. So many things can be modeled as springs that it's worth understanding the potential energy that a spring can contain. So once again, in order for there to be potential energy, we got to think of a system. In this case, the system that we are interested in is the spring itself and whatever's connected to it. Because a spring by itself doesn't have potential energy. A spring just sitting there doesn't have any potential energy. It can't push or pull on an object. It's only when I put it in a system with something else that can compress it or stretch it that suddenly the spring is able to do some work. For example, when I compress the spring, it can exert a force on an object over a distance as it expands back out, like so. Right? I can even use it to launch something, right? If I let this all go, it's going to launch this ball, like so, as applies a force for a distance. So the system for a spring is the spring itself and whatever's either compressing or stretching it. Now, what does the potential energy of a spring depend on? Well, it depends on a few different things. It depends on how much you either stretch or compress the spring. So if I stretch it, there's some energy. If I stretch it further, there's even more energy in there. If I stretch it even further, there's even more energy. If I let it go, it's going to hurt now. Similarly, compression. If I compress it a little bit of energy, more energy, more energy. So it depends upon the amount that the spring is either compressed or stretched. Now, it is independent. So let's say I take this spring and I compress it about an inch. So this is about an inch. So I compress it about an inch, also known as 2.5 centimeters. I get a certain amount of potential energy. If I stretch it an inch, I get the same amount of potential energy. So it doesn't matter if I compress or stretch, the amount of potential energy that I get is the same in either case. So it depends on the amount you stretch or squish it. But it doesn't matter whether you stretch or squish it. The other thing it depends on is the spring itself, the so-called spring constant of the spring. But this is just a measurement of how stiff your spring is. So here I've got two different springs, this little yellow plastic one and this metal one I've been using so far. And the plastic one is a lot less stiff than the metal one. See, I can squish the plastic one with just my fingers, no problem. The metal one requires a decent amount of hand strength to squeeze it. So we would say that the metal spring is stiffer. It has a higher spring constant than this little plastic spring. So those are the two things that the potential energy of a spring depends on. Depends on how much you either squish or stretch it, and it depends upon the properties of the spring itself. You know, a little plastic spring versus a metal spring versus, DNA. If we were modeling DNA as a spring, that would have a different spring constant. So the spring constant is just a property of whatever spring you've got. Normally, you either are looking it up or you're measuring it. There's no real way to know the stiffness of a spring just taking it off a shelf. You have to go and you measure it. And we'll talk more about that later. But for now, each spring has a stiffness that you would either measure or look up or solve for or whatever like that. And it's just a property of whatever spring you've got. And so different springs have different stiffnesses. So to summarize, again, one last time, the potential energy in the system of a spring and whatever it's compressing or stretching it, that's the system, depends on two things: the amount you compress or stretch it, doesn't matter what you do, and the type of spring it is. Is it a little flimsy plastic spring or a stiff metal spring or DNA, something, whatever. This concludes this video.